Thank you, Charles. Thanks, Charles. Very, very much appreciated, everyone. And thanks to everyone for taking the time out today from your busy schedule to attend this webinar. My name is Jay Padgett. I'm the program director of the Cultural Facilities Fund. And I know many of you, and in the past 15 years, this fund has made over $150 million in grants to 550 arts organizations across the state. We've been very grateful to play this role in the increasingly expensive work of repairing facilities. Since inception, I think we've taken pride in our relatively hands-off approach to the types of capital projects that we fund. We have preferred to follow your lead since you have a front row seat to your maintenance and replacement needs. We have only asked that you plan thoughtfully and give us insight into how your current project fits into the context of all your capital needs. So now that the Commonwealth has set a target of net zero greenhouse gas emissions by 2050, and emission reduction disclosure ordinances are becoming a reality, it's obvious that if we build new facilities or renovate existing ones, we now have to consider how these projects fit into the context of reducing carbon. In order to help us better understand emission reduction standards and the technologies that will help us meet those standards, we have asked our friends at New Ecology to share their expertise in sustainable building. We have also asked some of our colleagues to share their challenges and accomplishments in reducing carbon emissions. You'll be hearing from Historic Northampton, the New England Botanic Garden at Tower Hill, Cape Repertory Theatre, and the architectural firm Bruner, Cott Associates, who has worked with the Huntington Theatre and Mass MoCA. Our hope is that through this presentation, you will see options for yourself. We will also be hosting a webinar on December 6th with the Mass Save program, who is administered by Eversource.
This meeting is being recorded.
Oh, okay. Get some feedback. We will also be hosting a webinar on December 6th with the Mass Save program administered by Eversource, National Grid, and the Cape Light Compact, so you can hear directly from them what resources are available for cultural facilities. At this time, I'd like to introduce Marty Jostin, the Director of Product and Service Development at New Ecology, and Jonah DeCola, also at New Ecology, and he's the Senior Energy Engineer. They're going to kick off the presentation. Marty?
Thank you, Jay, and welcome to everybody. It's great to be here on such a beautiful morning. I will take 1 minute and tell you about New Ecology. As Jay said, I am a director there. There are several directors. I've been there for 11, 12 years now and have spent most of my time working on building specific projects, existing buildings, and on kind of strategic work with owners of portfolios of buildings, trying to help them prioritize and figure out on a larger picture how to move their projects forward and achieve their goals. And by and large, that's what New Ecology does. We do new construction and existing building work. We are a technical bunch in that we really try to fill that need, acting as a sustainability consultant for our clients. We're very mission driven. Most of our work has been done in the realm of affordable multifamily housing, but not all. We do work in nonprofit buildings as well. My colleague Jonah, who you're going to meet a little bit later, is a senior energy engineer, as Jay said, which is a title that's almost too small for his skill set. He's a plumber, he's a contractor, he's got loads of practical experience that you'll hear today, I'm quite sure. First of all, we collectively, when putting this together, thought we would define some terms. I don't know well enough this audience and where you are in your journey towards decarbonization. So we wanted to get some of these terms out because you're hearing them more and more. So net zero, as Jay mentioned, so that's really kind of the balance between, how do we get to zero between what we emit and what we can sequester in some way, or reduce and sequester. So the idea is to bring those two things in balance, get it all to zero, or get the net zero. A lot of times it's referred to as carbon neutrality. That's another phrase you might hear. Decarbonization is what we're all talking about these days. It's the result of what we do to reduce or eliminate fossil fuel use in your building. It is oftentimes referred to as, or used interchangeably with electrification, and that's not really quite accurate. Electrification is one way in which you can decarbonize, but there are other ways as well that you'll hear about today. We have deep energy retrofits, which is really a way to systematize, just really take a deep look into your buildings and the connections between all of your systems, your envelope, everything, and really come up with a plan over time as to how you can reduce your carbon emissions. It goes further than the standard energy efficiency program audits go. New Ecology, we refer to it as zero over time. So that's another phrase you might hear. And then CO2e is sort of the carbon footprint language. It's the metric for making a standard measure of greenhouse gas emissions. So you'll see this in terms of like per square foot as you apply it to a building. And I would say if there are other phrases that we talk about along the way, if you want to just throw those into the chat at some point during or after, we can try to get at some of that. We really don't want to lose anyone with the language. So as Jay mentioned, the Commonwealth has a goal of net zero by 2050. As you can see here, it is clearly not alone in having aggressive goals. All of New England does, and pretty much every state in the country does. It's typically some type of an energy plan that starts it. We have recently the Clean Energy and Climate Plan has sort of resulted in a roadmap to get to 2050. And then legislation comes behind that. We have the most recent bill passed in June of 2020, which is that H4515 I mentioned there. And it is, it states clearly that Massachusetts, the approach to achieving these limits, to achieving net zero by 2015 is to electrify non-energy use, to decarbonize the electric grid, and to reduce energy and the cost of the transition. And there's a concerted effort to try to make that transition as equitable as possible. For instance, Executive Order 596 established the Clean Heat Commission, which is due to come out with policy by the end of November, that talks about making sure there's equitable access to the opportunities this transition presents and to the costs that are borne by this transition. So that's kind of a smattering. There's a lot of action happening every day around this in the Commonwealth and elsewhere. And then as far as the grid goes, so the grid is, ISO New England basically operates the grid for New England. And it itself is challenged with, by law and by these plans to reduce its own emissions. That's one of the first things it needs to do. So right now, your electricity is likely emitting more CO2e than a gas fuel building. And that's because a lot of electricity is produced with fossil fuels. right now. So that as the grid cleans itself up by us adding wind power, hydroelectric, solar, et cetera, it will be actively reducing the emissions of what it takes to provide electricity. While this is happening, it's also the load's increasing, right? Everyone's being pushed to electrify. So what are the things the grid needs to do to ensure the capacity to provide that electricity to all of us? And then what are the incentives to drive people in that direction so that we are able to adopt that increased electrification in how we run our systems. So there's a lot going on all at the same time. And I'm not advancing. There we go. So a couple of drivers I just wanted to put out there. So yes, there's all that backdrop I just gave you, that context. But there are think tanks working on how does this play out. How are the prices going to go, and different pieces of policy and all of that. So this is something that was put out by Applied Economics Clinic, and they're experts in this type of analysis and modeling economic systems and climate emissions and things like that. And they've really nailed down kind of this window from 2026 to 2030, in which it's going to become less expensive to be heating your building with air source heat pumps than with gas. So it's really right around the corner. And this assumes a certain adoption rate of air source heat pumps in this case, because that's what that's what most of the incentives are around now. And it also assumes that, as you're getting people off of electricity, you are also increasing, you're reducing the pool of those that are paying for the gas infrastructure. So that cost may rise. So those are some of the things that go into this thinking. And then you can see ground source heat pumps, which Jonah's going to touch on later, is way down the curve. So this is just, an estimate of annual fuel costs over time. Another driver are benchmarking ordinances. So Jay had also mentioned this. So the one that has been out there the longest is Boston, the Berto ordinance. There's an ordinance in Cambridge, and the state just passed a reporting ordinance. So this is coming and will just be expanding. Originally, the city of Boston just required you to report and then report on some action that you took, to reduce carbon, or you could buy renewable energy credits in order to comply with that ordinance. This year they came out, or last year they came out with new regs that say, okay, we're going to look at your building use and we're going to tell you what your targets are over time. And that's what you're going to have to report to us. And not only that, you're going to have a third party verify this. So this ordinance is getting more teeth. Other ordinances will be developed and will also transition in that way. So soon enough, this is going to be a reality, probably statewide. So those are additional reasons for you to be working on this problem now. And here's what that looks like. So here's what this all culminates. I had mentioned zero over time is how we refer to decarbonization when we're working with a client on their buildings. And there's really 3 lines on this graph. I know it's hard to read. The bottom, the x-axis is our years. The y-axis is that measure of emissions per square foot. And the thinking here is that you start off, and this is a simplified graphic. You start off with whatever your baseline is now, and you measure what that is, and then you work with new Ecology, or you work with your engineering team, and you come up with, okay, here's how this is our capital project and our attempt to decarbonize. You implement that work the next year, and then that slope follows the same slope from that point on as the grid getting cleaner. So that's what this red line is for. That represents the electric grid weaning itself off of fossil fuels. So the slope of that building will also then follow that same trajectory. And then the green line here represents, in this case, the Berto ordinance and the compliance states and what those levels are. And this is for multifamily use. So what this does is give the owner a view of how well they're complying and how well they are approaching zero in 2050. Obviously, you can sort of redo this exercise over time because it's hard now to predict exactly what happens in 2050. So I just thought it was good to give you a view of kind of the big picture of what we're trying to do. We're trying to, the grid's trying to reduce, we're trying to reduce our buildings. In some cases, your buildings need to comply with an ordinance, and we expect that that need to grow across the state over time. These are various decarbonization approaches that Jonah's going to be talking about next. On the right's a graphic that kind of shows you how important buildings are to achieving decarbonization. This is a US graphic. In Massachusetts, actually, I believe transportation is the largest sector. In Boston, this graph would show buildings being like 70 to 80% of the graphic. So it depends on what you're looking at, where you are. But in general, buildings are half of the problem that we're trying to tackle. So I'm going to hand this off now to Jonah, who's going to kind of hit on these issues, and then we'll go a little bit later into the individual projects. Okay, Jonah.
Thank you, Marty. Hi, everybody. So we have big challenges ahead of us to adapt. So lots of changes ahead. And I thought that it was important to understand for all of us, we could all understand, well, so how do we get there? How do we reduce our load? And how spending money on these things, what the impact for energy savings is. So this comparison here is showing that using envelope intensive building, so that's jargon for how much insulation in the walls of your house or your building, or your, how well insulated the envelope is, the exterior shell of the building. So the pros, we call it an envelope, and really what we mean are the walls and the floors and the roof. So spending money on the envelope for the cost provides longer term and more affordable energy savings. The cost is lower because it also affects the mechanical system. Mechanical systems that provide us with the heat or the cool ventilation that we need. We're all combating the weather outside. So it's important to understand that mechanical systems are a way to get there, but as we get deeper into energy savings, we have to use more of them and at higher costs, and they don't last as long. So we could go to the next slide. So here's a example of what an envelope energy savings looks like. We have a retrofitted house, and we're using a thermal imaging camera. Thermal imaging cameras are what folks like I use to see temperatures. So we can see that the red and oranges on that color spectrum are the warmer temperatures. Yellows, and then as we get into blue, the blue is colder. So this is a retrofitted row house that has an envelope intensive investment. And because of it, they probably have more snow on their front steps and maybe on their roof than the other buildings. So what's important to understand with, how do we define the thermal envelope? It has to be continuously insulated. It has to, so any places where there's we would call a bypass, any weak spots in the envelope, you can think of my grandmother yelling at me about zipping up my coat on the way out the door in the wintertime. Because, if you have a bypass, like or you're missing your hat, it will affect how much energy will be lost. And so what this does is, by creating a warmer boundary of insulation on an envelope, we can then, this graph on the left is what temperature water we would need to supply to radiators or convectors to keep our building warm, and so we can see that on the graph on the left, we start heating at 70 degrees. And as it gets colder outside, as we get down to 0 degrees, right, our design temperature of the coldest day, we can see that the water temperature that we need to, say, provide to our radiators has to increase as it gets colder. So by insulating the envelope of the building, we can reduce the temperature of water that we're sending to the building. And that's important because heat pumps, which I'll soon to talk about, can only deliver temperatures that are less than we expect. Okay, so how do we improve our envelope? And considering all of the folks that are on the call, a lot of us have buildings with a historic fabric in the neighborhood that's important to keep, right? So that first beautiful picture of the barn with a slate roof in the beginning of this presentation, how do we insulate a building like that and not ruin the way it looks? So this is a project that I worked on when I was a deep energy retrofit contractor for the National Grid. And we used it as an example to show how to do a historic retrofit of a building. So dense packed cellulose, that's pretty common for how we're insulating older wood frame buildings, but sometimes it wouldn't provide enough energy savings for cutting the energy of this building by more than 50%. We brought the actually 65% reduction here. We used a structural insulated panel that also provided wind shear. And here we are putting it on the roof of this building. These are large, they look like ice cream sandwiches. You can see them in the right-hand side of this, and they're structural insulated panels that we're putting on the roof. And right, it looks horrible. So what we did was, like, you're not going to put that on any historic building. I'm sure I can hear you all talking in your minds about who is this guy and what's he trying to pitch here. So if we can move to the next slide before it gets more painful, this is the completed project. So as you can see, what we've done is we raised the roof line and kept the proportions, the golden mean proportions, as architects would say, with the existing structure. And this is a super insulated house that they replaced the gas meter on 4 times because they were sure it was broken, because the energy consumption was so low. What if you have a brick building? Is another thought that I could imagine. Well, I have a brick building. So in this case here, the picture on the right-hand side we have a historic facade, a brick facade, street side. And so we can't touch that. But what we've done is we've clad the sides and rear and roof of the building with rigid insulation. And the technique here is what we've done is we tried to make certain that we don't have any direct seams. So we staggered the seams of the rigid insulation. And then over this insulation, we've applied a cementitious clapboard. So it looks somewhat historically relevant. It's fire protective. And it's another deep energy retrofit to a masonry building. So on the ISO New England, which Marty talked about, right, the grid operators for all of our energy, in their plan for how Massachusetts is going to get to zero, and the rest of the community, it's all relying on this technology, which I'm sure you've heard about with Europeans and the war in Ukraine, perhaps, if you listen to the news. I don't know if anybody does anymore, but the plan is to use heat pumps. So these heat pumps, we're talking about all of us collectively using this technology that is essentially uses refrigerant. So we have a mix here of ground source heat pumps. That's the GSHP on the top. Those are, those rely on using the ground for a source of energy to pump into your buildings. And then we've got 40% air source heat pumps that may need electrical backup. And then some might have, fossil fuel that might be a biofuel. All of this means energy is going to get more expensive. And so when you think heat pumps, right, you probably think of this scenario. This is a mini split where you have an exterior outdoor unit over on the left there. It's usually elevated and it needs to be so that it doesn't get buried in snow. And it uses refrigerant that's pumped through pipes into the building, into these heads. We call them mini split.
We call them P to 8.
So we have these mini split heads. And so the refrigerant that is pumped from the outside unit is pumped through these pipes. Now, refrigerant piping is brought through the building or put on the exterior of the building, and that's another risk.
And that's another risk.
So the risk that we have is that refrigerants are a potent greenhouse gas. So we've started to make rules on not using refrigerants. The refrigerants that we count on to operate all the heat pumps that you might be thinking about is actually being phased out. Biden just signed that into law, and it's a good thing because the impact of refrigerants would put us into the same conundrum that we're in with global warming as carbon emissions. So we can see the phase down that's happening here on different types of refrigerants. The other problem is with refrigerants and using the air is that as the air temperature gets colder, the productivity, the amount of energy that our outdoor units can gather from the air is lowered. So we have to size these heat pumps to be able to deliver the load that our buildings have. And hopefully we've lowered that with an envelope improvement. But the productivity of the units need this electric backup, possibly. So that was that other slide that we saw before, where there was 40% of the air source heat pumps with electric backup. Because at these cold temperatures, we may not be able to achieve that. So that's this graph on the right, where we're looking at capacity at different air temperatures, and the load is the green line, how much energy the building will need at those lower temperatures. So that's the challenge that we have. And so the recommendation that I've been making is that we don't use refrigerant. Let's get that part out of what's being brought into the building, because that's a risk. And if it gets phased out and we have a problem in 10 years, then we're faced with trying to cannibalize somebody else's system to get their refrigerant, because they're going to stop making it. So this is another alternative. We have a self-contained appliance that's on the outside of the building, and it has its own refrigerant in it, but it puts its energy directly into water. And so we're looking at a couple of piping schematics where we have water being taken to the outdoor unit. It's being, the energy of the outside air is being put into it, and then it's being distributed into the building. And that can be distributed into what we call fan coil units. So it can be both cooling and heating, depending on what the load is. Now, the graphic on the left is a little bit more complicated for, say, a larger building that might have both cooling and heating needs at the same time. Cooling and heating needs at the same time, right? You say to yourself, who's doing that? Well, we all are. When we want to dehumidify air, when we want to make air nice and dry, we need to cool it down, get all the moisture out, and then reheat it. Well, in this case, the one on the left is a larger building that's applying this same technology, and we call that heat pump to water. So instead of using heat pump refrigerant air to air, as in the mini split slide that we saw before, we're using water, and water can be applied and last in our buildings for, I don't know how long, it's undetermined, maybe 100 years. I've been in buildings that have a hydronic system, we call it, baseboard hot water radiators that are over 100 years old. Proper management of the chemistry of the water, it can last indefinitely. Okay, I can hear you saying now too, all right, what about that historic building? I can't put something this ugly on the outside. So the next slide is, well, yes, you can put the outdoor unit on the inside of the building. So what we're looking at in the picture in the center here is the outdoor unit that's designed to be put inside the building. And we're bringing the outside air in, pumping the heat or cooling out of that air, and then rejecting it to the outside again. So we can, I put this in for those folks that have the custodianship of historic buildings. Now the water from this unit, this is a air to water heat pump that's inside. The water is being put through pipes into pumps, and those pipes with the pumping power then goes to convectors. And what's on the left here is an example of a convector by Meissen that has a condensate pan. It can do heating and cooling in individual spaces with occupancy controls and vacancy controls on it, so that we can keep our buildings warm. And we're placing these convectors in maybe in place of where radiators used to be, to provide cooling and heating. using an air to water. Now, the same idea of geothermal, right, which is in our slides is GSHP, the ground source heat pump. It's basically the same principle. It's a heat pump that has refrigerant in it, but it's getting its source of energy from the temperature of the earth. So here we have an example of a picture on the left. It's a messy operation. I've had to do it into driveways sometimes in the middle of the city, like in Cambridge, where we've drilled a hole for a well hundreds of feet into the ground. And in that, cooling the drill bit, you get this slurry that comes out. And so it needs to be fenced in. It takes about 2 days to drill a well. And these wells then are a place to gain heat from. And so no matter what the temperature is outside, we don't lose productivity. We don't have any outdoor air units or indoor air units. And we're pulling the energy from the ground or dumping energy from the building into the ground. And so the schematic on the right is showing a ground source heat pump loop that's then on the very bottom of the picture on the left, and that's pulling the ground loop into a heat pump, and then similarly making, say, domestic hot water or heating or cooling for the building. So that's what we call geothermal. Now, where you can see that today, if we were to put in geothermal systems in our buildings today, that's this orange line on the very bottom. It costs less to operate today than gas per year. But the investment is much larger because we have to drill wells. And so those wells can add up. If we need multiple wells, it's multiple days of a drill of drilling on site, and those wells have to be around 20 feet apart. So hopefully air source heat pumps will catch up with their technology as gas gets more expensive. The other benefit of ground source heat pump, those wells can sometimes also be a source of potable water, like a drinking well. So as we all get off of fuel burning and then start leaning on the electricity grid, the prices at certain moments of the day where everybody needs heating or cooling are what we call peak demand. And peak pricing, some of you might be familiar with demand charges, can be very expensive, and we can count on those being more expensive as time goes by. This picture on the left, we have two pictures, one of the graph of this scenario of the cost of energy during a day, the capacity of that energy, and when we get into the demand periods. So some folks think, oh, great, I'll have renewable energy. Well, so if you have solar and you have the capability of solar or wind, you can reduce that demand if you're producing at that same time. But what we've learned from places that have been early adopters of solar, like California and Hawaii, is that some folks that install solar systems or wind turbines can't sell their electricity at certain times of the day because the grid has enough of it. Everybody's fine. And we can count on that happening as we do this adoption. So that's where we'll think about having batteries, where we can still make electricity through renewable energies on site, store them in batteries, and then we could reuse our energy on site during those peak demand periods. This picture of the building behind is some work I did for MIT, where we put solar panels on the roof of an structural insulated panel building. Now batteries in the future also are probably going to be in our vehicles. So we may not need to have a battery system in our buildings. We might have a fleet of cars that plug in that we then pull from when our building needs heating or cooling during this peak demand period. So that would be like a battery bank on wheels. When it comes to domestic hot water, we have heat pumps that don't rely on refrigerants that are potent. So there are some heat pumps now that are CO2. They're actually, the refrigerant is carbon dioxide. And those, the cost of installing those, they don't have any greenhouse gas impact because the refrigerant is the same as carbon dioxide and not thousands of times greater. And the cost for those is equivalent or less than doing what the picture on the right here is. That's a little bit of my artistic work. That's a solar thermal system where we're taking direct energy from the sun and putting it into domestic hot water. So the cost of heat pumps versus solar thermal seems either equal or that heat pumps might be a little less. So that would be doing showers and so forth. Now, another piece of our challenges is ventilation. As we get our buildings tighter and more energy efficient, we're not going to rely on the leakiness to provide ventilation as we do on a lot of buildings today. So we're going to need to bring in fresh air from the outside. And all of us have just gone through a refresh on what a pandemic does to inside air. And so how do we bring in fresh air and not increase our energy loads? So this is a piece of technology that should be part of your scope of work. Is called an energy recovery ventilator. And energy recovery ventilation basically allows for exhaust air to be the energy, not the air, but the energy in exhaust air to be recycled and used to preheat or pre-cool fresh air. So we reduce the load by around 50% on treating that new fresh air with the exhaust air. And so this is an energy recovery ventilator, and the incoming air oftentimes has to also then be continued to be tempered or made comfortable or dried so it's not humid, but we can save around 50% of treating that fresh air if we pass it through an ERV. The other piece of work that we do at New Ecology is we also look at your building, your site, and do a risk assessment on vulnerabilities, the same questions that have gotten us into this mess, the climate change and adapting and resilience is part of the way we need to do business. If we're going to spend money, we need to think about ensuring that our buildings are resilient. So here in this case, you can see that, well, an adaptation would be a flood panel that could be put in front of this otherwise disaster of not necessarily coastal flooding even, but also inland flooding where there's heavy rains and backflows in sewerage and the rest of it. So here's an adaptation, a flood panel, but it's how we do business. So as an example, we'll look at a site that we're working on, the Fine Arts Work Center. And so when we take on a project, we identify, here's an opportunity, we're going to take money and we're going to spend it on improving the building. And what that means is complying with all of this work that we're talking about in this presentation, but also included in that is resilience. So we do a risk assessment, including of identifying carbon, energy, water improvements into the capital planning. So a lot of our work is looking at historic energy usage. We understand what the baseline is, how much water is being consumed, as in potable water, and then a physical inspection and measurements of the building, and come up with a win-win recommendations. So that we're looking at more of a holistic approach that includes addressing the vulnerability and risk assessments that come from data, and then putting all those recommendations into energy savings estimates to pay for the work. So Resilient Mass, here's a website that is put out by our Commonwealth that will do risk assessments that you can use to look up your properties. And it's one of the ones that we use. So this site is way out in Provincetown, the tip of the Cape. We call it P-Town, right out there at the very end. And so, is it coastal flooding? Well, I don't know. So let's take a look. So we ran this project through that, and we've come up with risk assessments and hazards. So if we can move to the next slide. This is not an abstract painting made by the artists, but in fact, we're looking at the tip of the Cape there, and we can see where the inland flooding is. It almost actually pinches off the Cape, the end of the Cape, into an island if we had a large storm coastal event. But luckily for this particular building, we are not looking at flooding, but we can see that we have real issues with wind and the 140-mile-an-hour wind zone that this building is in. Let's think again about what is an adaptation that we can do. We know we need to reduce their energy. So we're going to recommend a win-win situation that both does energy improvements and makes the building structurally sound to take the impacts of a storm and provides a place that will be habitable and a safe shelter during a long period of maybe no energy from the grid. It's probably likely that power plant or the utility connections might be down. So that's part of how we make our recommendations. We consider co-benefits, right? Measures with co-benefits are insulation, air sealing, and window replacement on this property, where we're going to have heating and cooling and energy savings. Improved passive survivability. We're probably going to put some solar panels with a battery system so that it can be used during these periods of loss of energy. Improved wind load performance, improved comfort, improved functionality, and reduced maintenance. Right? That's what we need to deliver to make sure to help this custodian of one of our community's benefits, the Fine Arts Center, keep these artists and folks going. Now, we could just look at it and say, well, we'll make a measure without co-benefits. Like, all right, well, let's give you a backup generator. And what does that mean? Well, a backup generator means increased building services like maintenance and operation and fuel storage. So we try and think about the long-term costs of operations, because that's what you're faced with every day. So that's pretty much what I felt like I could overwhelm you with in a short period of time.
Thanks, Jonah. It is a very complicated set of things that we're working with, and trying to balance all of those capital demands and timelines and everything is definitely a challenge. And we're going to hear about a couple more challenges now. We are going to first hear from Laurie Sanders from Historic Northampton. I think you're co-executive director, if I have that correctly.
That's correct.
Okay, so I'm going to advance your slides for you, Laurie. Just kind of give me a hint, okay?
Okay, well, I think since this is a statewide program, I thought I would just first orient people. We are located in Western Mass, as Marty just mentioned, and specifically we're located right where there's the star near Northampton. So if you proceed, Marty, you'll see our. So this is our, we own just a little over 2 acres, and we own 3 historic houses and 1 historic barn, which was the first image. So if you continue clicking, Marty, I'll show images. So we own something called the Damon House, which is our newest house. It was built in 1813. The Parsons House, which the front is from 1719 and the back is around 1811. And then the Shepherd House, which is going to come up, which was built in 1796. And then in the rear of our building, these are all along the street, the rear of the building is the barn, which if you click that last slide, which is the image you saw at the beginning. So at Historic Northampton, part of our mission is sustainability. But our primary mission is maintaining these 3 historic homes and the barn. They are the most important artifacts within our collection of somewhere around 40,000 objects. And so in 2018, we were really fortunate. We worked with a couple who formed a private LLC, recognizing that nonprofits are basically ineligible for the SREC credits and the federal credits. And so we have an agreement with them where they paid for the solar panels that were installed on a roof of our building, which is the only new building. It was constructed in addition constructed around 1989. But this is another issue I think that confronts all nonprofits, but that the way the systems work in terms of, we had more square footage, we had more real estate on that roof, but in terms of the economics, our system was only 10.39 kilowatt hours. So it was the one place that we were able to build it. Here's the benefits that we've seen since we installed it. So it's made a big difference for our building. And as someone had put in the chat earlier, in terms of cooling and heating at a museum, one of our big challenges is keeping humidity levels at a certain point, and then also keeping those collections cool. And as everyone who's on this webinar is and affiliated with the Historic House Museum knows, historic houses are not were not designed for collection storage. So there's that whole challenge. And here at Historic Northampton, the other piece that we have is we have a preservation restriction on the entire property. So if you can advance, Marty. So just a quick summary. This is our, we have a mix of gas and oil. And I have the 2020, 2021, so pandemic levels where in the Damon House, that's our museum, offices, collection storage. Parsons House, which is our most historic building, at the moment is just used for collection storage. So we don't heat it in any formal way, just keeping it at the bare minimum. And Shepherd House is currently rented as office space to Mass Humanities and also has some collection storage. So these numbers reflect sort of some changes, but just kind of as a snapshot for us to look at how do we reduce our fossil fuel consumption. We're using just in these last few years somewhere between 2,500 and 3,000 gallons of either gas or oil. And our electric use at the Damon, our solar panels help us reduce our electric consumption by about 50%. But you know, we have a lot of electrical needs, and part of that is humidifiers and dehumidifiers depending on the season. Okay, you can continue, but you see that we have some high use. So we're trying to figure out, because right now we're doing this very much Rube Goldberg approach to addressing our humidity levels, where we are dehumidifying in the summer, and then once the furnaces kick on, we're humidifying in the colder months. So it is it seemed like it would make a good short-term solution, but it's a lot of staff time, and lugging containers of water up and down in collection storage area is really not good museum practice. So we did two things. In 2021, we thought, okay, well, how can we address this sort of long-term humidity temperature issue and reduce our fossil fuel consumption? So we worked with this, you can see this proposal from Western Mass Electric, which included air conditioning and upgrades with a I think it was an air source heat pump. But it was expensive. It was $55,000. And one of the pieces is, you know, it wasn't getting us entirely off fossil fuels. It was a big ticket item. And we thought, well, wait a minute, we don't necessarily have all the answers. So this year we were very fortunate to have Ben Wheel from UMass, who used to work with one of the Mass Save companies, and he did like a real rapid assessment, a much deeper dive than you get with a Mass Save inspector, and looked at all three of our buildings in a single day, and then prepared a report for us, which you see here. And it includes, you know, some like very much low-hanging fruit kinds of solutions, but also you know, more expensive ones. So if you continue to the next slide, you'll just give kind of a summary of where we're at. And when the other co-director and I met Jay at another MCC function, we started talking with him about how, as a museum, we have, and as a historic house museum, we have a lot of challenges. We have very much a goal to move towards carbon neutral, but how do we get there? And so we're under a preservation restriction. Our buildings are old, so we like the building insulation in the walls is not an option. We probably can't run mini splits on our walls. Solar on the roofs has its suite of problems. Geothermal, potentially that's something we could do here. It would be really a very neat opportunity to see if we could do it where we feed all 3 houses, but it's going to trigger an archaeological survey, which for those other organizations here who have done archaeology surveys, they're so important, but they're very expensive. And at our site, you know, we're fortunate, we have a bigger site, a couple acres, but we're limited in terms of our property size and shape. And then the other piece for all of us who are on this call, who are listening to you, is that, you know, it's not spot on our mission, these costs. And so that's a key piece. I have just 2 more slides to address some of these other things for us. The other important thing for us right now, and that made it such an important difference of working with that private LLC with our solar panels, is that we're, as a nonprofit, we're not eligible for many of the state and federal financial incentives. We're also, Mass Save has been a challenge because it's, you know, you either have a commercial account or a residential account, and there's not necessarily a good fit for what our goals are. I mean, we've had some major benefits in terms of electrical upgrades through Mass Save, but we have, I don't know for what reason, historical artifact per se, is that one of our buildings has a commercial account and 2 others have residential, and those are not the same. So figuring out if there could be some new special grant program through Mass Save would be terrific. The other piece is, you know, we're listening to Marty and Jonah, but these kind of expert teams to come in and help us make a decision where we're looking at high costs, that's really tough to find. Who's on your team to really give you that comprehensive assessment? And so as we advocated with Jay, figuring out if there's some special grant program that we could have, like technical feasibility, to do a, you know, a comprehensive overview to identify an appropriate path for different institutions. And I really would hope that with DOER and the SMART program, that there could be some other provisions to help organizations like ours. You know, we want to be part of that, especially, I mean, I love the thought of being a historical society that's at the cutting edge of this approach, but it's expensive. And so, and we have a lot of limitations with our maintaining the historic fabric. So every decision we make, even the low hanging fruit, we have to have a preservation consultant or a conservator evaluate those. So anyway, it's complicated. It's exciting for me to think about all these pieces, but I really feel like for those of us in working in arts and culture institutions, our focus is different. So having access to experts who can provide good advice would be very, very beneficial. And then, of course, some grant opportunities would be really, really exciting. So that summarizes my presentation. Thank you, Marty and Jonah, for giving me the opportunity.
Sure. Thank you, Lori. That's not an uncommon need across organizations. It's just the ability to obtain and pay for the kind of experts you need to tackle these complicated situations. So there are some resources I'll be talking about later that may evolve into that. So hang in there. Miranda, I think you're going to change presenters now, and we're going to hear from Mark Richardson, the Director of Horticulture for the Tower Hill Botanical Gardens.
Thank you, Lori. Thank you, Marty. Oh.
So do I pause share? So I'm not sure.
Can everybody hear me?
Yes.
Okay, thank you. Sorry about that. Let's see. Mark, welcome. I think that you should be able to share your screen. If you stop sharing, Marty, then Mark will be able to pull up his presentation. Wonderful.
I think I'm good to go, right? Excellent. Can everyone hear me okay? Fantastic. Great. Thanks for this opportunity. I was really honored to hear from Jay a couple of weeks ago, and to be able to shine a spotlight on some of our work here in central Massachusetts. So we're New England Botanic Garden at Tower Hill. We are close to 40-year-old botanic garden just outside of Worcester in Boylston, Massachusetts. But we're a fairly old organization. We're the Worcester County Horticultural Society. We were founded in 1842. We own and operate New England Botanic Garden at Tower Hill. And what I'd like to do this morning is just share some about what we've been doing to try to improve our carbon footprint here, and talk a little bit about the work that we've done, and then some of our plans for the future. So again, just really appreciate the opportunity to be here this morning and to share some of what we've been up to. So I wanted to take a quick step back and talk about our strategic plan. We completed our most recent strategic plan during the pandemic. So we worked with a consulting firm out of Louisiana called Trepwise. Actually, 2020 was a fantastic year to do this. We were able to meet with our constituents and our board and other key stakeholders over Zoom through the whole process, and it was a really great process, and I'm really pleased with the result that we wound up with. But I wanted to highlight a few of the pieces of our strategic plan that speak to the work that we've been up to. So first, our plan is organized into 3 pillars. First is horticulture. We are a botanic garden after all, so I think it makes logical sense that our first primary pillar would be at the heart of our mission. And what I'm most excited about with the plan is that from the get-go, the very first strategy, the very first tactic is about sustainability. We've really baked this into the DNA of our organization. So our very first strategy in this most recent strategic plan is to benchmark and develop an action plan to improve the sustainability of our landscape operations. And that's the majority of what we've been up to the last couple of years. The very first tactic is to convert fossil fuel burning landscape equipment to electric. And that's primarily what I'll be talking about this morning. The other 2 pillars are leadership and engagement. And under our leadership pillar, one of our strategies is to invest in team development and expertise building. And that's the other component of what we've been up to the last couple of years, is investing in our staff, allowing them the time and the resources to investigate solutions for tackling challenges. And so I'll talk a little bit more about what I mean there. So supporting staff in completing professional development opportunities that expand their practical knowledge base so that they can share that with the wider world. And then finally, engagement. So we're really committed to teaching plant-based solutions to climate change and sustainable horticultural practices through our gardens and our programming. We're getting ready to break ground on a climate resilience garden that we hope will reach school-age children and their families in understanding how they can make decisions in their own property, whether it's a small urban property or a larger suburban space. We want to make sure we're serving as an example for people to take lessons home about how they can be better stewards of their land. And one of our tactics is to interpret plant-based solutions to climate change and sustainable horticulture through the garden. So we've been on a journey the last couple of years to really eliminate our carbon footprint in our landscape operations. And we've done this in a number of different ways. First and foremost, we're looking at modifying our landscape practices. So prior to 2020, this is what we were doing. We had at the time probably about 10 or 12 acres of turf grass that we were mowing. So we were mowing twice weekly with a 4-stroke ride-on mower. I'm going to use a little terminology. So a 4-stroke engine is like the engine in your automobile. It has separate gas and oil. So you have a dipstick. You can check the oil in your engine. most landscape equipment is 4-stroke. So a lot of our mowers, small utility vehicles, which means there's a separation between gas and oil. You're burning gas and using oil for lubrication. But we were also using 2-stroke equipment as well. 2-stroke equipment burns a mixture of gasoline and oil. Emits a whole lot more carbon into the atmosphere, much more damaging for human health impacts. Think about the operator who's running a string trimmer for several hours a day and all the emissions that they're breathing in as they're operating that equipment. So we were mowing twice weekly with our 4-stroke riding mower. We were blowing off all of our paths with a 2-stroke gas blower, either on a regular schedule or as needed. And then we were string trimming all of our turf areas as well. And keep in mind, we're a botanic garden. We're open to the public 7 days a week and trying to get all this work done before 10 o'clock in the morning every single day so that we were open and ready for guests. This is just an overhead shot of the property back in 2019. You can see all the exhaustive or all the expansive turf areas. A lot of what you're seeing in this image was carefully manicured turf grass. And we've made a lot of changes in the footprint since then. So beginning this or the last couple of years, we've been under a lot of construction. We've also been modifying our landscape operations. So we've expanded our parking to accommodate more guests. And through doing that, we eliminated a lot of turf grass and planted a lot more meadow spaces that require a whole lot less maintenance, certainly a lot less regular maintenance like we were doing before with all of our turf areas. The meadow spaces allow for more greater biodiversity, allow for a lot more pollinator habitat, allow us to educate the public about the carbon impacts of different management strategies for the landscape, but it also allowed us to adopt some different landscape equipment. So we met back in 2020. Or 2019, we met a gentleman named Dan Mabe from the American Green Zone Alliance. The American Green Zone Alliance is a nonprofit organization based in California who works with the landscape industry to encourage adoption of zero emission landscape equipment. And we were just recognized last week as the first Green Zone certified botanic garden in the country in a small ceremony that was held here at the garden last Thursday. So we've made a pledge to implement the usage of sustainable landscape equipment and to control of all of our carbon outputs through our equipment. So these are our new landscape practices. We in 2020 purchased a 48 volt, 48 inch mower that we use as our primary mower now throughout the garden. So we no longer are burning fossil fuel to mow any of our spaces here. We're doing it all with an electric mower that you'll see in the last slide in my presentation. We've also replaced all of our handheld power equipment, or most of our handheld power equipment, with battery operated equipment as well. We've chosen to go with Husqvarna battery powered string trimmers, chainsaws, handheld blowers, forestry clearing saws, etc. So we've been purchasing a lot of equipment and replacing all of our carbon burning equipment as we go. We've also purchased a number of Ego blowers. Ego is, Husqvarna is really a line that's produced specifically for landscape industry professionals, whereas Ego equipment can be found in Lowe's, Ace Hardware, lots of different hardware stores. Ego makes mowers, they make blowers, they make string trimmers, they also make snow blowers. And so we've started using a lot of Ego handheld equipment as well, really demonstrating that it is possible to operate a large landscape operation like ours with a fully electric array of equipment. All of the tools have been field test certified by the American Green Zone Alliance, and we've done our own research. I have a staff member, our land steward named Robert Graham, who's done a tremendous amount of research and a tremendous amount of his own field testing to really see what would work best for all of our staff. And we've made some changes to the way that we do fall and spring cleanup, leaving a lot more leaves in place rather than sucking up every leaf that falls to the ground. It's a great interpretation tool for the public to show people that leaves are a fantastic mulch. It's a carbon intensive process to collect leaves in the fall, and we're much better off just leaving all that material on the ground and allowing it to decompose naturally. And then finally, we're mowing a lot less grass. We mow maybe around 4 or 5 acres of turf now compared to the 12 acres that we were mowing just a few short years ago. And it's had a great impact. We're using this equipment in the middle of the day. It's very quiet. It doesn't burn any fossil fuels. We can run our mower, at 1 o'clock in the afternoon without really disturbing guests who are walking around in the garden. And it's a great conversation piece. It's a great starter for conversations with people about the equipment that we're using and really trying to encourage them to follow suit and use electric equipment at home. We've got some other equipment that we're in the market to be replacing. So on the right is our old Bobcat skid steer. We use it primarily for our snow operations, for moving bulk material around. And just a couple of weeks ago, we demoed this giant G2200E lithium ion articulating loader. And we're looking at replacing our skid steer with this electric loader, hopefully in the next year. And I did want to mention that Massachusetts last year announced a program called the Diesel Replacement Grant that pays for about 40% of the cost of a large piece of equipment like this, maybe a diesel burning generator. And so there are funding sources out there that are available for both nonprofits and for commercial entities to take advantage of. The only caveat is the piece of equipment that you're removing from your fleet has to be destroyed. So we can't sell our Bobcat to someone else and buy this piece of equipment and take advantage of that funding. We've got to make sure that we're actually demolishing it so that we're taking that diesel motor out of service. And then just a couple of other quick slides here. Back in 2019, we worked with a group of students from Worcester Polytech to develop a carbon footprint calculator specifically for Tower Hill. And so every month we put our usage of electric that we purchase from the grid, propane, oil, even water into this calculator so that we can track our usage over time, calculate our carbon footprint, and then make decisions about which direction to head with efficiency initiatives. And one thing that led us to is putting solar on our horticulture barn. So in the image here, you can see the horticulture barn. It's a 4,000 square foot building. It's where most of our equipment is parked overnight. We have a lot of electric utility vehicles that we use to drive around the property. We're 180 acres altogether. It's quite large. And all of our equipment is charged up overnight in this space. We're looking at putting actually integrated photovoltaics roof replacement onto that barn sometime in the next couple of months, thanks to a grant from the Mass Cultural Facilities Fund. And we have a lot of other fish to fry. We've got diesel boilers, propane boilers that need to be replaced over time, but we've made a pretty substantial impact here in replacing our landscape equipment because the technology is there that we can embrace it now. And I'll stick around for questions later on. Really pleased to be able to share with you this morning. Thank you.
Thank you so much, Mark. Greatly appreciated. So now we're just in the interest of time, we're going to move on to Jason Forney from Bruner Cott Architects presentation. And Mark, thank you so much again for that really thorough, informative presentation. We are, just so everybody knows, we do see your questions in the chat, and thank you so much for contributing. We're going to do a Q&A at the end once we get through everybody's slides, and we'll open up the floor. So thank you. With that, Jason, feel free to take it away.
Okay. Hi, everybody. I'm Jason Forney from Bruner Cott Architects. And I'm going to shift scales a little bit. Our primary work is larger scale transformations and renovations of buildings and often cultural facilities. And I'll admit that I made this slide as Jonah and Marty were talking, but this isn't something that is a secret. The real path to decarbonization is reducing your loads, using efficient and electrified systems, and generating energy on renewable energy on site when you can. And so I've been fortunate enough to work on a lot of really great historic buildings over time. These are some of them here. And also a lot of great projects that are cultural facilities in Massachusetts. And so I'd like to just share some specifics about two of them that I think demonstrate the path to decarbonization fairly well. And those are the Huntington Theater, which was completed about 2 weeks ago, a major renovation, and Massachusetts Museum of Contemporary Art, or MoCA in North Adams, which we've been working on for as a firm for about 25 years. And I will acknowledge that these are major renovations, bigger projects, but I think that the point of view I have is that when you decide to do a renovation like that, you have to take sustainability and decarbonization into consideration. And I think that you also should be held to a higher standard, because the financial resources are there, the ability to change things, upgrade envelopes, switch out mechanical systems is there. And it's something that you need to do. So I'll, like I said, I have two projects to share some of the details on. And the first one is the Huntington Theater. This is a 1925 historic theater in Boston, along the Avenue of the Arts, Huntington Avenue. It's a regional theater. And so this was a major planned renovation. It really hadn't been touched very much since its original days. And so here we have an opportunity to do a full replacement of the mechanical systems, but also, like a lot of others were saying today, this is a historic building. This was a historic tax credit project. So we had to balance and manage the change with allowing the historic building to still maintain its significance and all of the things read through that were important about the building. A lot of things had been damaged over time. The front terrace had been removed. The theater had been painted in a different way. And so there were more opportunities to do things. And the result, or the outcome here, is that we were able to, and this is still a prediction through an energy model, reduce the energy use of the building by over 70% compared to its existing state, which is about 50 kBTU per square foot a year. And within that, we were able to do that using 80% of the energy sources are electric and 20% are natural gas. Now, we wanted to go for 100% electric, but there were some challenges that we decided to back off of, but also leave room and leave space for conversions over time of that last 20%. And so, our strategies to do so, first of all, I think recycling old buildings is imperative and is a major element in our fight against climate change. That, removing these buildings and replacing it with new would expend tons of carbon for all the materials that have to go into it. So this is a big first step. We did not upgrade the envelopes in the most historic part of the building because it would have affected its appearance too much, either by changing the way the historic auditorium looked or changing the way the building facade looked on the avenue. So instead, we insulated where we could. And that happened to be on the roof. We were replacing the roof. And then there's a whole wing behind the auditorium, which is the dressing rooms, costume shops, offices, and things like that. And there we were able to insulate the building from the inside and replace all the windows. With public health concerns, the project does include a brand new ventilation system with increased ventilation rates and high levels of filtration for that. So that's something we were fighting against because that takes energy, but felt like it was imperative. All of the theatrical lighting has been converted, or as much as possible, to LED. And then in old buildings like this, a lot of energy we find is wasted through inadequate controls. So that was a major part of our situation here. So the systems that run off electricity, there's an air-cooled chiller. There's a dedicated outdoor air system that you heard Jonah talk about with heat recovery. We used basically mini splits or VRF for all the back of house. And then we used, instead of steam driven radiators, we converted to electric radiant panels. And then the pieces that we felt like we couldn't move away from was there is a small boiler which serves the heating coils associated with the air handler, and then the water heating is also done by gas. We considered on-site solar here, but because this building is part of a larger development, there's a residential tower going next door that's 30 stories or so that would have blocked what otherwise is a nice sunny roof, and so we decided to move away from that. So that's the Huntington. Next project is MoCA, which as I mentioned, we've been working on for a long time. And I'm really going to talk about the third phase because like a lot of evolutions, the first two phases were done. Well, first phase was done in the late 1990s and the second phase in the middle 2000s. But I think as we got to the third phase, these sustainability and carbon concerns had become more apparent and were more incorporated into our work here. So this is a large building. It's 120,000 square feet, the third phase. Again, the opportunity to replace the mechanical systems. And in this case, we were able to reduce the energy by almost 80% over the national average for a museum. We don't have any data, comparative data, because the building was sitting vacant and unheated for a really long time. And in this case, almost 90% of that is electric and about 10% is fossil fuels. So we're moving in the right direction, although not 100%. So again, recycling a whole lot of existing building. We chose, and this is another frontier, I think, for in our profession of architecture, is choosing materials that are inherently low carbon, because we've talked a lot today about operational carbon, but I think embodied carbon is something that needs to be considered too in the design process. And here, such an incredible part of MoCA is the exterior on the outside and the inside. And so we did not upgrade the envelope. We were able to upgrade the windows and the roof in a similar way to the Huntington. And a big part of our strategy here, this is a huge building. Each floor is almost an acre. And so the artwork is within these kind of pavilions within that larger floor plate. And those pavilions each have a tighter level of climate control. Some of them are just heating and cooling, and some of them do have humidity control. So by not trying to do the whole entire building, we focus our energy. And then, you know, as you're walking around from pavilion to pavilion, it's okay if the comfort level is not the same there, because you're active and you might still have your coat on. It's not uncomfortable, but it's just not, you know, perfect. This project was also done with a separate ventilation system, dedicated outdoor air, and then also with VRFs or heat pumps. Lighting again was converted to LED and a high level of control. So most of that is electric driven, but there is we made a connection to the existing boiler for the heating coils in the ventilation system and for a makeup air unit in the kitchen. But again, moving a big step towards electrification. And that was coupled with a 200 kilowatt array that was financed by the state. That was done before the renovation, and that provides about 34% of the electricity that the building used. So I hope it was helpful for you to see. I know these are different scales. I hope it was helpful for you to see these. I do think that every project has its own set of circumstances and goals and objectives, and the solutions all look different. But these are two that I thought would be nice to share with you today. Thank you.
Thanks, Jason. That was great. And congratulations, Mark, on your project. And thanks, Lori. I mean, you guys definitely have been busy working on all the right things. So this is great. I'm going to share my screen again. We wanted to next speak with Janine Perry. Right, okay, sorry. Janine Perry. From the Cape Rep Theatre in Brewster, where I have spent many a summer hour, and let her kind of just talk about her project and her questions. It's just a way to kind of get any question and answer going with the group. We dedicated about 30 minutes to this. I don't know that we have quite 30 minutes left to spend on it, but so Janine, why don't you go ahead?
Thank you, and thank you for inviting me today. After listening to all the speakers, I think that I would like to at least say that what I turned in has been covered by so many other people. It might be best to state that we are in the middle of a project. We have a live permit on a historic structure, which is not what you see there. That's our indoor theater. And that historic structure is a barn that was built in 1889 and moved to its current site and exists on our campus of buildings, recognized as an historic site in the state of Massachusetts. We are tenants, long-term tenants with 55 years, with legislation passed in 1994 to enable this project. So our primary mission is a theater for the performing arts. But our secondary mission is that we have promised the state of Massachusetts to be stewards of this historic property, which was formerly a camp, a summer camp. In particular, we're at a stage in the restoration of the historic barn on the property, and we had our pens poised over a contract to enter into a phase of the project which installed the mechanical systems. And we paused the project in light of all of the concerns globally and nationally and locally for climate change, and in light of the legislation that was recently passed. And so here we are, we're without technical assistance in evaluating what we should be doing. That is the primary focus we have at the moment. And we have listed a number of things to Jay in preparation for this as to where we're at in the process. And they seem rather basic questions that many of you are facing, and so are we. I think where we differ from everyone else is the urgency with which we came to this moment in time, and that is that the contract was on the desk and we called a pause because primarily of climate change. And we lacked the knowledge and we lack the technical proficiency to make decisions about how to go forward. So I share with Lori the necessity for expertise. And I also recognize that we're going to have to look for some money for that or some assistance. So all of the questions you see here on this slide are pretty much reflective of what everyone else faced or may be facing in the future. I think where we stand is, and how we differ from everyone today is we're small. And this is despite the fact that we have a different mission. We've had trouble finding assistance. So we've had a design team. We have a permit pulled on the entire project from soup to nuts, from beginning to end. The building is small too. It's 72 by 35 or 2,500 square feet. We have a basement we installed in a previous phase, and going forward, the structural systems followed by the final finish work for what in essence will be a small theater function space, a home for our educational programs. So that is very urgent to us as well. But here we are, and I think we're educating ourselves. We're in need of technical assistance. I thought to myself just a moment ago, instead of keeping you all on some of the other questions I had here to pose to Jay previously, I think it's self-evident, and I'm open to questions on our project. But I think that it would be just reviewing the ground that you've already covered. So just wanted to tell you how we differed from everybody else. So, yeah.
I'm sorry. So I think, yeah, I mean, the ultimate answer to all of your questions is like, well, you know, it's hard to tell from a PowerPoint slide deck exactly what kind of advice any building needs without more of a deep dive. I know we wanted to go to some questions and answer. I want to kind of turn to you, Jonah, and talk about, you know, see if there's anything you wanted to say specifically about this list of questions and this building, this project, or any of the other projects that you've heard. And then certainly, Miranda, I know you've been monitoring the chat just to see what kind of questions have come up. And, you know, this is sort of a free form period of time here where people can raise their hands and ask what they want, and we'll see where this goes. But for now, we'll take the slides off.
Thank you, Marty, and everyone. So I think maybe we could start with, if Jonah, if you had any, or Jason, or anyone has any input for Janine at this moment based on some of the questions on the slide. And I do think we're going to keep following up with you, Janine, to try to go deeper, as Marty said, to try to connect the dots here.
Could I ask Janine if you would ask the questions, because the slide has now been taken down. And so if you wanted to just ask each one of your questions, or
All right.
are important to you, it would also be helpful for everybody to hear them instead of maybe reading them.
All right. One of the biggest questions I would have is where to get some technical support for where we're at and where we should go with our project. To me, that's one of the most important things, is the lack of knowledge, the lack of direction, and what journey we need to take is very, very important for the financial packages involved in a project at this point in time. We have a design already for an HVAC in the building, and therefore we're perched at this particular time in evaluating that, and whether we should be, as the previous presenter said, strategizing, leaving space for what to do down the road, or whether we should go forward at all with what we have.
So to that question, I think what I saw on the slide was that, can you reuse the ductwork? And the answer is yes. Heat pumps adapt very well to ductwork. And you said questions about heat pumps. So I hope from the presentation we have a few choices on different types of heat pumps, right? For both for using the air source or a ground source heat pump. So a ground source heat pump also suits well if you have a lot of property. Instead of drilling a single well down, maybe you can use what's called a field of going horizontally under the ground. But nonetheless, the answer to your question, yes, you can use heat pumps for ductwork. Part of what's important to think about for all of us is how do we use the space? So if a space is going to be empty, how can that space adapt to being left feral? Meaning, like, can we turn off the heat? Can we drain the pipes? Can we dehumidify the space? Maybe there are months of the year that you may not use this space. You know, the second home is a huge impact on our energy consumption, right? All these empty houses for the folks that have luxury problems, unlike myself. But how do those spaces handle lower temperatures by getting dehumidified so they don't get moldy when they're empty and cold? So those are some questions that came up for me about your space. I did check while you were talking, and you're not at risk of any flooding in the site of your location, which is good. If your barn is going to be reused or used year round, maybe some of the overcladding on the exterior. I'm assuming that you would love to see the internal post and beam work in the space. I'm guessing of the barn itself. So an overclad of insulation on the exterior in that slide that I showed of that historic house renovation may be a consideration. The other thing to consider as well is how people experience temperature. And we are, as human beings, we're radiant creatures, right? When you stand next to a fire, even if it's cold outside, you can feel warm because of the radiant energy that's coming from a fire. So maybe the idea with your space might be to put in a radiant surface on the floor, for instance, that would make people feel warmer instead of trying to heat all the air in the building, which is an enormous task. You know, that was similar to what Jason was describing about using electric radiant panels. Those probably provided comfort, a feeling of comfort in a space that's warm. I would love to say, you know, call me anytime, Mrs. Perry. Miss Perry. I'm happy to help you, but Marty's my keeper. But I'm sure New Ecology that, you know, Jay may be able to help align you with resources that maybe we can help you. And I appreciate all the work you're doing.
Well, thank you. I think that our building is at the point where it's been through several phases. And so it's completely historically restored on the exterior, roof, siding, everything. So we're perched here with a designed system utilizing gas, which we have on the entire property. And that's why we paused. And so we have less options open to us on the cladding on the exterior or on the roof. And we have an open space. Nothing's been done. We've just removed paneling to restore. And we were ready to go with the infrastructure items like the HVAC. And I'm really proud of our organization for pausing, but it is creating problems of all kinds, you know, financially and otherwise. So we feel an urgency to make some decisions soon.
So I think what you're ultimately after is sort of that longer term planning process, that the zero overtime plan, the deep energy retrofit kind of thinking, where, you know, to make sure your resources are being spent at the right times and not precluding other decisions down the road, and all of that as
Yes.
You know, capital needs get spaced out so that you can afford them over time. And you know, there's some funding coming. It's not entirely clear the use of that funding in many cases. There is also in the 3-year plan, you know, the energy efficiency programs that as ratepayers we all pay into, Mass Save. They go in 3-year planning cycles, and you know, some of that stuff I presented early on, but you know, the pushes on decarbonization and in trying to align those program offerings with that mandate and those goals, because they're not quite aligned yet. And some of that relates to you know, within the plan, this 3-year plan period, which just started this year, there is supposed to be testing of the deep energy retrofit offering from these energy efficiency programs. So that is something, I don't have any more information on what the plan is there. That's something perhaps that can be raised on the upcoming webinar with the Mass Save program. Is just really trying to understand how they're evolving to meet the decarbonization mandate with their incentives. And and raise the issue about, I think now for you to be able to get the kind of help you need through Mass Save, it would have to go through a custom program that requires a lot of engineering expense, et cetera. So yeah, it's not easy, and it's not clear how much they would offset given how much savings you would get from a building of your size. So small buildings are particularly tough not to crack.
They are.
Yeah.
So that is why my concern is not to proceed to do anything that would foreclose decision-making along the way.
Yeah, that's the right instinct. It's just getting you to the next step. That's the
Yes.
problem right now. Amanda, I'm going to ask you, do you have things in the chat that came up that are questions, or anybody have questions about something they're facing on their own project or decision they're struggling with, anything that we might be able to help with?
Thank you, Marty. Yeah, so I think we'll start the Q&A now, and I'll just go ahead and read off some of the questions that we've received in the chat in the order that they came in. So Tom O'Shea had a question for you while you were presenting, Jonah. And he had asked earlier, with the concern for increasing heat island effect, how will the envelope insulation impact internal summer temperatures?
Right, it's a great question. So heat island effect, just for those to understand, is essentially that a lot of our surfaces, like our, say, parking lots, are paved with dark surfaces, and the sun heats those up. And so you end up with these microclimates where you have what's called heat island effect. The city of Chicago implemented putting in white roofing as a mandate and lowered the temperature of the entire city by 3 degrees because they removed a lot of the heat island effect by putting in highly reflective surfaces. Okay, so on the question, will insulation provide affect the internal temperatures and heat island effect? And my answer is that what insulation gives us is a way of controlling temperature. So with insulation, I would say, why don't we cool the building off at night? Hopefully the temperatures at night are cool enough. And then we can bottle up the building during those moments of high temperature. It's kind of like the old style people used shutters on their windows to reflect the sun's energy during the hot part of the day, and then ventilated the buildings at night. So I hope that answers that question.
Thank you. Jessica Howard had a question. Have you worked much with integrated earth buildings, or buildings that are essentially, they have a living roof or are under a hill like a hobbit house? And what heating, cooling source would be recommended? She's considering pellet, as their needs would be minimal due to the insulation of the building itself. This is for a new build for a cultural and educational building at a wildlife sanctuary site.
So I would recommend that, that using as much of the local materials as possible, like this earthen roof, which has benefits because it captures moisture and slows runoff during rain events. And then as it dries, it naturally cools the building, like we do when we sweat, that latent heat that's pulled off of us. But when it comes to burning pellets, which have some benefits, I would say, will also and maybe look at something called gasifiers for biochar. We recently made a recommendation for a nature preserve site to use a gasifier. What it does is it pulls the energy off of wood, but leaves charcoal behind. It gasifies wood and does what's called carbon sequestration. And that also was providing and creating electricity at the same time of doing carbon sequestration. Sorry for the jargon. I must be like, what is this guy talking about?
Well, and
Can
Jonah,
I just want to, I put something in the chat, but I think, looping back to what Janine said, this goal of having some kind of technical resource team is just, it's so valuable for all of us, because I felt a little guilty working with that that business to develop the HVAC bid, which just it was a big time commitment on their part. And we want to be, good neighbors and not waste any of our local business people's time. And anyway, it's just, I just can't overemphasize like how if we could have some kind of regional task forces or anyway, I'm with you, Janine.
Can can you? So one quick comment on that, Janine and Lori, is, and anyone who's on the call, if you send me an email just stating that, it'll help me build a case to find resources to have a technical assistance team on demand, which is, it's going to take some resources to do it. But I'd rather show community support and sector support for just this very idea. So if anyone on the call, my email, I'll put in the chat, send me an email, just state a simple case of why this would be important to you, and I'll take it from there, and we'll be back in touch. So wanted to just say that.
one other point I just want to add on real quickly is, and I'll be just quickly talking about the Infrastructure Reduction Act. I'm sorry, Inflation Reduction Act. There are a number of pots of funds that are not particularly well defined yet, but several of them relate to community-based organizations and community-based efforts. So another way to slice this, right? You as an organization could be looking at pooling resources, or maybe within your community, you guys are all parts of your community, that resources could be worked across the community. So again, there's just not enough information to say more than that, but there is money coming through that act that is targeted at nonprofit organizations in communities.
Janine, you have your hand raised.
Yes, I just wanted to emphasize in the need category for technical assistance, just navigating through the legislation and understanding not only what it is, but the timeline for its implementation is extremely important when you're in the midst of a project. All of our constituency that is involved in this particular project is always going to have asked, and continue to ask, when will you know what incentives you can take advantage of? When will they be present? How long do we have to wait? So that, Jay, will be part of my email to you.
The other, just without, I'm only going to spend a moment with my gibberish here, Janine, but I want you to write down gas absorption heat pump systems. Actually, just I'll send it to you in it's Einstein's invention when he was just a lowly patent office, a clerk. It's one of his patents, Einstein, and it's not decarbonization, but it's using a gas absorption heat pump your site, you said, has already been outfitted with gas and you're using ductwork. And a gas absorption heat pump creates 140% of the energy and is actually equal to the pollution of the grid right now with heat pump systems. It's not a long-term benefit, but considering your short time and short-term problems, it's a consideration on a product that's will be rebated tremendously through a custom application that utilizes gas if you don't have the electrical capacity at your site to go to heat pumps. Sorry for the gibberish, everybody. I just couldn't let that one pass.
Thank you all. I'm going to move us on to the next question. Robin Glazer did ask about more info on the Mass Save webinar coming up in December. We'll put that on the website later on. Just wanted to acknowledge your question, Robin. That will be announced on probably in our newsletter, and we'll have it on the agency dates page. Let's see, we have something here from Melanie Trottier. She says, our museum was built and renovated very sustainably. CIPs, or I don't know this acronym, CIPS, 2 huge solar installations. We are confused on why our costs are still so high and if we will ever recoup the money. One PV system has SRECS, and that money has gone down a lot, and the other has a bi-directional meter, so we have no idea how much electricity is being generated here, apart from the data system installed by our solar company. What do you recommend?
So that's a common problem that we encounter with folks. How do you support somebody that has a difficult puzzle? So one of the ways that I describe my job at New Ecology is the local trash man, because we end up with really difficult puzzles. And what Marty and I do for most of our day job is we actually install sensors and use data collection with a cloud where we beam up data to a cloud to troubleshoot problems like that. Where is the energy going? And instead of us spending hours on the site and to figure something out, we'll put sensors on the site, collect the data, and then spend an hour reviewing maybe a month or 2 of patterns to be able to actually give an informed description. Now, you don't have to necessarily count on Marty and I, but I would recommend, to answer your question, is to do some data analysis that uses time to see where your energy is going. We oftentimes get brought in, and the trash man comment comes in, that we get brought into buildings that are built broken. They're broken from the beginning, and no one knows why. And so the trash man for me is picking up the trash. It's actually figuring out why and then fixing it. And it's quite satisfying when we actually fix it, which we do. Unfortunately, we fixed everything so far, which means that we keep getting work. And unfortunately means that, there's a lot of trash out there. It's.
Can I add a comment? Which is, so as you all know, we have these 3 historic homes, one of which is the one where we're based, and on our 2nd floor, we have collection storage. So in terms of collection storage, those windows were open. They had shades on them, just inexpensive, cheap shades. So we worked with a conservator and we installed a foam and then a panel, and we had black on the outside, so our buildings looked nice from the exterior. But it's even that, I guess what I want to emphasize is the importance of follow-up. So we had this fellow from UMass come, and he had his heat gun, and it from our side and the exterior looks good, thank you very much, but honestly the foam is not as insulative as we thought. So the windows, they're just bam, they are still letting in a tremendous amount of heat. And since basically the way air conditioning in these historic homes gets up is just passively going through the walls, there's appears to be a duct up above, but thank you very much. It's just sort of like moving through the walls and getting up there. So we have real serious issues with keeping that area cool in the summer. And in the absence of that follow-up, so that's my point here, is just like, do the work, but like this person is writing like, oh, we're still struggling. And I never would have known. I just felt like, okay, off the to-do list, that's done, but it ain't done. And so I don't know what's next, but we definitely we have 14 windows, 20 windows upstairs that they all need to be redone somehow. I'll definitely write to you, Jay.
So I realize we're getting pretty much, we've run the course of the 2-hour webinar. We did have a few slides of resources for you, and if anyone wants to hang for a couple minutes, we can go through those just so that we can point you to some resources. And Marty, I think you have that.
Yeah. Seconds.
I will say that in the new IRA, the Inflation Reduction Act, there are benefits for direct pay to nonprofits.
You're stealing my thunder, Jonah.
Sorry.
Okay, so super quick. These are kind of the areas that we wanted to talk about ever so briefly on resources. The Inflation Reduction Act is the big federal bill with $1 gazillion that's just was signed into law mid-August. And there's just a lot of work right now deciding how that money is going to be, the rules around spending that money. It's going way more to buildings. It's also workforce development and transportation and grid cleanup and all those kinds of things. But there are definitely resources coming to buildings. They're focusing on disadvantaged communities, et cetera. The one thing that I wanted to make sure you knew today was that the investment tax credits, there are several of you that had mentioned the arrangements you had with a third party or having to create an LLC so that there was an entity that could take the tax credits, that could monetize that incentive. With this new act, now anyone, organizations that are exempt from paying taxes, which is all of you, can receive a direct pay incentive. So you can be your own developer and your own off-taker. And the gist of the benefit to you is that previously it was a 22% tax credit. It's now going to be a 30% tax credit. So if you have a $100,000 job, you can shave $30,000 off of that cost right out of the gates. And then there are other things that can only increase that percentage benefit to you. So if you have, so that's all I can have time for now. It also would apply to geothermal projects as well. So huge benefit to those of you. And there are other incentives coming out of this bill that we just don't know about yet. Here's some information on the upcoming webinar on the Mass Save project, December 6th at 2. I'm sure Jay's going to be sending something out about that. Again, I would ask about what's in the 3-year plan and how they're going to evolve their offerings to support decarbonization. Equipment systems and performance optimization is really key for all the existing buildings out there. So there's some potential incentives there that you probably don't know about.
So I have a meeting with the Mass Save folks next week to shape the content of the webinar, and I encourage you to participate. And you can also send me any questions or any challenges you have had interacting with Mass Save, and I'll make sure they can address those.
And then my last input is this, Jonah mentioned us doing this data collection. We've had for a couple of years now a grant awarded from Mass DOER that allows us to collect data and analyze it real time. The intent of that grant several years ago when we started was focusing strictly on central gas systems and an extended contract so that we could, work on improvements over time, over a 3-year period and all of that. There might be some ability for us to work in some benefit to those of you if you want to talk about this. For instance, the upfront assessment we do could be a subset of kind of a decarbonization look, and there are still dollars available for monitoring equipment that can, again, help you figure out what you need to do. All right, Jay, back to you.
And then we have a Cultural Facilities Fund grant round that's currently open. The deadline is February 2nd. We have 3 different types of grants. We have the capital grants that go up to $200,000, feasibility and technical assistance, and then systems replacement plan. The feasibility grant can be used for testing any of the projects that you've taken that we've been talking about today. And the capital grant could certainly pay for the implementation of any of the equipment or any of the capital improvements that we've been discussing today. I think there's one little bit of an incentive we've incorporated this year in that you can apply for a capital grant and take care of whatever it is, that you need to work on in the facility. And you can also apply for a feasibility and technical assistance grant, provided that it is a grant to reduce carbon emissions or to make making the building more efficient, building and installing systems, anything in that realm. So you get the extra bump of being able to apply for a second grant in the feasibility realm, so long as it deals with what the topics that we're talking about today. And then the next slide will just be the deadlines are coming up February 2nd, and the grant announcements are in May 2023. There's a couple dates there for returning grantees where you have to meet certain milestones to be fully dispersed before you can send in another application. Grant people that received a capital grant in 2022 have to wait a year. So if you have any questions about that, you can certainly contact Miranda or I. And I think that wraps it up. I'd like to really say thank you for your participation in this. We hope to continue brokering information and making connections. And also, as has been talked about quite a bit, is having some on-demand resources that you can access to get some of the questions answered that are pressing and in real time. And with that, Lori from Historic Hampton, Jason from Bruner Cott, Mark from New England Botanical Garden at Tower Hill, and Janine from Cape Rep, and our partners, Marty and Jonah at New Ecology. Thank you so much for providing us all the content for this webinar. And if you have any, we'll be packaging this and putting it up on YouTube in the next few days. And if you have any questions, I'll put my email in the chat again. Thank you so much.
Thank you, Jay. Thanks, everyone.
Thanks, everyone.
This is Charles. A great big shout out to Travis and Amanda and Melissa for providing the communication services. Thank you.
Thank you.
Thank you, everybody.
Bye-bye.